So currently we are using k-fold cross-validation technique with 5-fold. So it will keep iterating with the 5 and the 5 times. Okay, it will keep iterating the 5 times. It also get rid of from the AUC results and also the recall matrices and precision matrices. So obviously the precision and recall going to be high and anyhow. So we are going to be checked with some of the slightly improvement with corresponding to the AOC ROC results. So if you take maybe we are just taking somehow, I think for the baseline columns, what we just now discovered with the baseline columns. We are not taking all the features. This is a somehow baseline models we are doing be trained corresponding to the k-fold cross-validation technique. We can also do with maybe all the features. So with this all the feature we are just training around, we are getting 0.78. So somehow slightly improving with corresponding to the, if you just apply with all the values. So what will happen if you do something called as a feature importance? So in this feature importance we have two mechanisms. One is forward feature selection, another one is a backward feature selection. So let me explain this with you. How does a forward and the backward feature selection going to be help us? So in this image, you can see we have all the features. This is the, you can say all the features we have in this spot. So you're going to be take all the features and recompute by using any model. What will happen if you take any feature and do some modeling, you will get somehow accuracy results or AUC results or a score. Let's take some score. You will get a score called 0.8 for this, and for this 0.7, for this zero point 0.6, for this 0.5, for this 0.3. So whichever having the highest score, we are going and take consider into our model. Okay, so currently we are using X2 is having more higher value when compared to the all other features. So we are just combining this into our model. Whichever having another high frequency or another high score, then we can combine to the other. So like that, we are just combining with together corresponding to the model evaluation what we had. So that is the reason we are just following as a forwardly, we are taking a feature and combining together in our modeling. So most frequently is going to be combined together at the end, but lesser number of the score, it may not be identified. Only we have to twinkle to take only for the 5 variables or the 10 variables according to our requirement. And something called as a backward feature selection. This is a reverse of operator when we had to combine with somehow feature with other. It what exactly is going to be do? We are going to be eliminate somehow whatever all the corresponding models we have. So we are going to be trained with somehow model corresponding to the x1 and also the x2, x3, x4, x5. So whichever having the low score, whichever having the very less score, it's going to be identified and it's going to be removed to our data set. So like that is going to be boxed out. But the major disadvantage with respect to the forward direction is we are going to be calculate twice, because we are going to be calculate at the data set side and also calculate at the model side. So this is very time taking process when compared to the backward feature selection. We are directly calculating at once in the model side and we're just removing or throwing out into our data set. So in this project also, we are going to be take consideration as a backward feature selection, or we can also call it as a feature elimination process, reverse feature elimination process. So it will take less time when we are applying the large data sets while doing the logistic regression. So that is a major factor to take, you can say elimination backward feature selection. So let's tie with that with corresponding our logistic regression, what we had. So this is a basic syntax for the, you can say reverse feature engineering technique. We will also get it from the scikit-learn. Feature selection, under feature selection, we will get it from reverse process or reverse feature engineering library. I can say it will takes around half an hour to compute this cell. Okay, the total cell having more number of the features we are going to be evaluated, but corresponding we are just taking only for logistic regression we have just applied on the top. Yeah, so these are the number of parameters in the, you can say reverse feature engineering process. Also you can also apply maybe the estimator to predict any kind of the model. Currently we are using logistic regression only. You can use maybe the other models if you want, and hyperparameter tuning, class weight, number of the iterations you want to be specified to compute or recompute your features, and then you eventually get the feature importance according to the ranking. So let's go and print with the ranking. I'm just printing the rank according to the future results. So you can see current balance having the rank first. That means the current balance holding the very future importance while doing some modeling, and average monthly balance and occupancy company. These are the some top 10 future or top 20 future we are going to be identified according to our estimator. Currently, we are using logistic regression. That is also very interpretable of the model. But whenever you apply some tree-based mechanisms, you can identify with respect to that. And also you have to fine tune your hyperparameter to compute very faster. So take top 10 features and recompute our logistic regression with k-fold cross-validation technique. Then how come our ROC result or some score we are going to be get? At some point we get around 0.78. I hope you remember, but at this situation we are going to be get 0.7 and slightly improving. You can also get at the k-fold fourth fold you're going to be get as 80 result. So like that is slightly improving. You can also see the second fold is going to be get as 81. So take the top 10 features and apply to our all the features what we had instead of taking only corresponding features. So in this case, you can directly apply with all the features. Eventually with the same results, you can also see eventually we are going to be take the same result. I think we are going to be take consideration for the all the features. Yeah, so let's also compare with all the features according to our top 10 features what we had. So you can see at the time of second for cost validation result and the first for cost validation results, all the top 10 features having holding the very future importance when compared to the all, and the model accuracy is also very high when compared to that. So around 0.881, right? So around 0.81 results we are going to be get at the top of k-fold cross validation. So like this, we have to tune. You can also try with the forward feature selection along with k-fold cross validation technique. So I will also send you a reference notebook with corresponding to the hyperparameter tuning. You can also fine tune your C. So this is also very good matrix to fine tune to get rid of. You can also try with penalty to change L1. What exactly the results will happen, and why we are you take consideration by default as L2 instead of taking as L1. So you can also play around with this data set. I can say when come just ignore as of now the KPI matrices we are just calculating as a scores.